This is the video 5 of MEKG video series. In this video, propeller and thruster topics are discussed. Topic 1: Oil Lubrication System.
Lubrication System. The lubrication system consists of a drain tank which acts as a reservoir for storage of oil. Drain tank is a double-bottom tank located in the aft of the engine room. The system consists of two sets of oil pumps. The purpose of having two pumps is that if one pump fails, the other pump can take over and continue the operation. Pump draws suction from the drain tank and sends it to the oil cooler. The cooler cools the lubricating oil and maintains the temperature of the oil within acceptable limits. The cooling medium used in a cooler is air or water. The oil reaches the full load condition header tank, from where it overflows to ballast condition header tank. Both the tanks have an outlet valve located at the tank bottom. Overflow from these tanks is led to the drain tank via a sight glass. Pressure head exerted by the oil level in the header tank and water draft are monitored by noting the pressure gauge values. A drain valve is fitted to check water intrusion. The small pressure differential of oil ensures water exclusion. The lubricating oil passes through the stern tube bearing. The oil pressure is sufficient to generate hydrodynamic fluid film lubrication. Since static head generates oil pressure, it is sometimes referred to as static lubrication. The diagram also shows a lubrication system for the forward seals. The oil circulation within forward seals is achieved by natural convection. Oil in the forward seal tank is cooled by a cooler. In some cases, the tank is provided with radiator fins on the tank surface. The air in contact with the fins cools the tank, which in turn cools the oil. You are looking at a simplex-type stern tube. The simplex stern tube consists of forward and aft seals. The seals work in conjunction with oil-lubricated bearings. The aft sealing assembly consists of two main and one auxiliary sealing rings. All sealing rings are spring-loaded and are able to seal any position of the shaft. The forward sealing rings prevent oil leakage to machinery space. Spring load and oil pressure of the system. Lip seals hold oil within the stern tube and accept slight misalignment. The elastic lip of each nitrile rubber seal grips the short chrome steel liners. Chrome steel liners are located at aft and forward ends of the propeller shaft. They act as rubbing surfaces for lip seals. The liner at the outboard end protects the steel shaft from seawater and corrosion. The lubrication system is connected between the two forward seals.
Topic 2: Airspace Seal.
This media will explain the modern air seal system used in brand new ships. This is a pollution-free system which totally eradicates any oil pollution into the sea. It consists of lube oil tank unit, lube oil filter, lube oil pump, drain collection unit, air control unit, and 4 lip seals. number 1, number 2, number 3, and number 4. The purpose of the 4 seals is to prevent any stern tube oil leakage, prevent seawater contamination of the stern tube oil. A constant quantity of air is supplied from the air source. It passes through chamber number 2 and chamber number 3 and is spouted into sea by lifting number 1 and number 2 rings. The air pressure in chambers 2 and 3 is always maintained about 0.1 bar more than the seawater pressure, so as to slightly exceed the tightening force of number 1 and number 2 rings. In conventional oil-lubricated stern tube sealing system, chambers 2 and 3 are supplied with lube oil instead of air, and the oil is likely to cause oil pollution at sea. With this air seal system, the danger of oil pollution is completely eradicated. The air pressure is added to the stern tube oil tank. The oil tank is installed at 3 meters, 9.84 feet, above a shaft center. The stern tube oil pressure becomes air pressure in chamber number 2 and number 3 plus 0.3 bar, and it follows the draft change. Any draft change can be automatically detected, and the air pressure in chambers 2 and 3 and stern tube oil pressure follow the draft change instantly.
Topic 3: Controllable pitch propeller.
A flange-mounted hub in a CPP includes a piston arrangement which moves fore and aft for making the blades to rotate by a crank arrangement. The application of hydraulic oil at a high pressure, 140 bars, through an OT, oil transfer tube, helps in the movement of piston. The ahead and astern oil passes through the inner and outer pipe of the tube. In order to allow the flow of oil, the tube is ported at any one end and is separated by seals. Through the ports on the shaft circumference where the OT box is mounted over it, the oil is sent to the tube. This sits on the shaft on bearings and is prevented from rotation by a peg. There are 3 sections in the inner bore of the box. The existence of positive pressure in the hub is ensured by the ahead and astern and also the oil drain attached to the hydraulic oil header. This helps in the prevention of air or oil ingress. The rigid attachment of OT tube to the piston makes the total length of the tube to move in the manner similar to that of piston when moving fore and aft. The tube is also attached with a feedback mechanism, which helps in monitoring the position of the blade pitch within the engine room.
Topic 5: Bow thruster.
Bow thruster. This media will give a clear understanding as to how a tunnel bow thruster works. A bow thruster is a transversal propulsion device built into or mounted to the bow of a ship to make it more maneuverable. It consists of thruster, hydraulic cabinet, gravity tank, centralized control device, control panel. This represents the schematic diagram of a bow thruster system. Power is transmitted from the prime mover through a flexible coupling, input shaft, and bevel gears to propeller shaft, rotating the propeller in constant direction. Prime mover is an electric motor which drives the propeller shaft. The propeller parts consist of 4 propeller blades, a propeller hub with a hydraulic servo motor, and a sliding block mechanism. The propeller blades are connected to blade carriers by blade bolts, and this assures easy replacement of blades in the thruster tunnel. The gear case, which carries propeller parts, is connected to the thrust tube by bolts, and this assures easy overhauling of all parts inside the tube. Pitch control for a thruster is very similar to that for a controllable pitch propeller. This tube has inner and outer pipes through which a head and a stern oil passes. The tube is ported at either end to allow oil flow and segregated by seals. Oil is transferred to the tube via ports on the shaft circumference, over which is mounted the OT box. The oil passing through the OT tube results in reciprocal movement of the servomotor piston. Pressurized oil from the solenoid valve is fed to the hydraulic motors via an oil transfer tube in the propeller shaft. This movement of the piston is converted to rotary movement of the blades by the sliding block mechanism. The OT tube is rigidly attached to the piston as the piston moves fore and aft, so the entire length of the tube is moved in the same way. A feedback mechanism is attached to the tube. This allows for checking of blade pitch position from within the bridge.
Topic 4: Construction and working.